repeat what you were saying?
Yeah, I've sent you a message on the Zoom chat. If you can just add the link there.
Sure.
Yeah. Hello, friends. It's Insaid here in India, and it's great to kind of host you for one more session on European Data Science Week here at Insaid. And today we have a wonderful speaker all the way from Berlin. So before I get into introducing Alexey to all of you, what I would do is I'll quickly kind of brush you through what we have done so far. And it's really great to kind of see such kind of enthusiasm across an entire week where all of you have been kind of very active. I presume a lot of you who are not able to kind of join through Zoom, you might have kind of informed your friends out there that there's a YouTube link that is live. So we'll primarily kind of sync up on the YouTube link. I'll be taking up questions there as well. So just make sure that we all are active on YouTube as well in case we are facing any challenge with Zoom. Okay, so with that, what we'll do is we'll get started for today. And let me first share a deck with all of you. So give me a moment, I'll share you my deck. Okay, yeah, so I think we are up. So, yep, so today is the final session for European Data Science Week. This is one of those events that we organize here at Insaid where we get speakers from across the world. And this time our theme was targeted towards Europe. So today, what we'll do is we'll kind of quickly recap of what we have done so far, and then I'll hand over the mic to Alexey to kind of take it forward for today. So as you see, we have had like great speakers from different companies, be it Multiply, Continental, Capgemini, and today we have Alexey from OLX. So I believe all of you have kind of got the golden opportunity to listen to all of them. And I'm pretty sure you're making your notes thoroughly so that we can all kind of make sure that whatever we are learning here, we start applying to our regular lives as well. So give me a quick yes if this is if you have attended all the 4 sessions so far, including this one. So give me a quick yes on your chat windows, and all the folks who are on YouTube, you can quickly kind of give me a yes on YouTube as well. Okay, excellent. So I see a lot of you have been kind of attending all of the sessions. Yeah, thank you. That's really great. For the ones who have missed out, I'm pretty sure you would have access to the recordings on our YouTube channel. Just make sure that all of you can go to the YouTube recording. Please make sure that you actively make notes, you learn from the speakers because they carry a lot of valuable knowledge from industry, and that's why we would want to kind of make the best out of it. So now going on to the next one. So today, if you see, so we had great speakers out there. So right from Philippa, Marian, Alexey will be talking today, and then we had I think Divyansh for the first day itself. Okay, and sadly, Mohammed then we couldn't make it because he has had a family emergency, because of which he wasn't able to get up join with us. But anyway, we had great speakers, and today we have Alexey for us. Okay, so this topic that we have covered so far were data science trends in UK by Divyansh, data science for social good by Philippa, overview of data science projects in IT industry by Marian, and finally, we have today Alexey, who's going to kind of talk us through how software engineers can transition to data science roles. And this is something that is very interesting because a lot of you are actually I would say software engineers by profession, or you might be kind of planning to get into software engineering roles, but you might be actually leading companies where software engineering plays a pretty important part. And along with that, you want to integrate data science. So Alex is going to walk us through what is the right approach, what is the right methodology, what is the right mindset that you should have to kind of make sure you get the best out of data science and software engineering, both in one place. So one more kind of quick glimpse about Alexey is he's a founder of Data Talks Club as well. I would highly recommend all of you to kind of follow this. Even if possible, please go ahead and enroll on and put up your email IDs here. Join the Slack channel. Keep following them so that you can kind of get started with his talk. Alexey, before you get started, if you can give us a quick glimpse of your past and a little bit about what is Data Talks Club to all our audience. So with this, I think I'll stop here. I'll stop sharing my screen. Over to you, Alexey. And first of all, warm welcome to you from the entire Insaid cohort. We have participants across on Zoom as well as YouTube. So yeah, I think everybody can say a quick hi to Alexey, and then we'll get started with Alexey. Okay, over to you, Alexey. Thank you for accepting an invite.
Yeah, thanks for reaching out. It's an honor to me to talk today. So you said I should start with introducing myself and talking a bit about the Data Talks Club. I will do it with pleasure. So maybe I'll first just talk about Data Talks Club because I have. No, that's us on YouTube. So like Data Talks Club is that's the URL datatalks.club. And this is a community of people who love data, and there are many things going on. So you can find people who you want to talk with about data, machine learning, engineering, discuss different career options like how do I transition from software engineering to machine learning, like the topic we have today. And we also have weekly events. So I do recommend to check it out. And I have a few slides about myself in the presentation. So I guess I'll just start with this. So this is the topic for today. Thanks already for introducing this. I will skip the slide. A few words about me. So I started my career as a software engineer. Back in 2010, I started working, like my original background was databases. This is what I studied in my bachelor. And then I started working as a Java developer. I worked for like almost 3 years as a developer, as a Java developer. And then around 2012, I accidentally, or one of my colleagues told me that there is this exciting course on Coursera happening about machine learning. And I don't think I managed to get into the first cohort, but it was one of the first ones. So I got there on Coursera, watched the course, and it was amazing. And this course changed my life. So then I realized that this is something I want to do professionally also. And I wanted to transition from doing Java in a bank to doing machine learning as a data scientist in some company. Back then, it was quite difficult to find a data science job. So companies were just trying to understand what it means. So eventually what I did, I got into a master's. I got a master's degree at the Technical University of Berlin. Then I graduated in 2015, started working as a data scientist. Then I worked at a startup called Simplex, and a couple of years later, I joined Elix, and now I work at Elix as a lead data scientist. And looking back at my career, at the way I transitioned from software engineer to data scientist, I don't think everything was optimal in a way that if I was doing something today, I would have done things differently. And I'll talk a bit about that as well. Yeah, so most of the things I'll be talking today are based on my own experience, which I captured in a book. So a book, I'm writing a book right now, Machine Learning Book Camp. The target audience for this book is software engineers, so somebody who can already code, coders who want to transition to software engineer, to machine learning. And in this talk today, I want to give you some sort of learning path. So you don't actually need to have a book to learn from this talk today. And what I want to tell you is, looking back at my experience, looking back at my past and things I did, how would I approach it today? How would I structure my learning? How would I structure my approaching the transition? And most of this is based on the book, which I wrote exactly for software engineers, and I'll tell you a bit about that as well. But I want to start with this picture. So this picture is a content moderation system we have at OLX. For those who don't know, OLX is a online classifieds website. And this is a place where you go if you want to sell something or buy something. Like, let's say you have an iPhone, you want to sell it, you go to OLX and you create a listing there. Okay, this is iPhone, you take a couple of pictures, you put this there, and you click publish, then the ad goes live, and then people see this listing and contact you, and yeah, you basically sell the phone. So when you're preparing this listing, when you're hitting that publish button, what happens is the ad doesn't immediately go live to OLX. What happens is that there is 1-2 minute delay where we look at the ad and we want to decide if this ad is safe, if it's safe to go to publish this live on our platform. And this is what our moderation system does. So here on this picture, like there are many different things. So we have a machine learning component here. So here you don't really need to understand what's going on in this picture. So the important part here is that we use machine learning a lot in this picture, but this is only a tiny part of the entire thing. So a lot of things that we do here in this particular system and in many other systems in general, they're not related to machine learning at all. So they're about connecting different systems. They're making sure that there are data pipelines are there, that there are systems for moderators to have a look at this, to act, to make the decision. So a lot of engineering stuff. And this is not a unique project. So if you look at other projects, the situation is similar. So there is a tiny little thing, tiny little service with machine learning, and a lot of things around that. And all these things around that, they are engineering things. So it's about connecting different systems together. And there is a famous paper from Google. So it sounds a bit like a cliche. Maybe you're rolling your eyes right now because you have seen this picture a lot of times, but maybe you haven't. And this picture illustrates how a typical system, real-world ML system looks like. And you see that machine learning is a tiny piece of the puzzle there, and the rest is infrastructure. So what it means is most of the work around machine learning is engineering work. And you, as a software engineer, you already know how to do these things. So you already have 90% of the required skills to make it work. So you have all these except this tiny little thing in the middle called machine learning, but you already know the rest. So you can already use your knowledge that you have already to be able to work on machine learning systems. You just need to fill this remaining 10%, and you're good. So you're enough. It's enough for you to do that. And the way you can fill this gap, the way you can approach studying this 10% is this is how I would suggest to do this now. So if you look back at my experience, I enrolled into a master's. It's a good idea to do masters, but you can think about this as a time investment, and you would need to invest 2 years in that. But you, as a software engineer, you already have all the needed experience for that, 90% of what you need. So you don't actually need to go to a master's and do a master's and spend 2 years doing that. Instead, what you can do is follow this plan. So you can start with fundamentals, and I will tell you a bit later what these fundamentals are. Then you go to simple machine learning algorithms like regression, linear regression, logistic regression. Then you spend some time understanding how you can evaluate these models, and this is quite important. Being able to say that this model is good and this model is bad. Then you need to deploy your model. And again, when it comes to deploying a model, you as a software engineer already know how to do this. Maybe you haven't done this with machine learning previously, but you have created web services. So this is not too strange, not too unusual for you. And then you gradually go to, once you can do all that, you go to more complex algorithms. And the way to do it, in my opinion, is the best way, is by doing projects. And I, as a software engineer in the past, I think this is the best way to learn. So instead of focusing on theory, I think the best way is to do projects. And again, looking back at my experience, so what I did is I did a lot of online courses. Online courses are useful, but I did a lot of them. So I didn't do just one. I didn't do just two. I think I did like 15 of them. That's a lot of courses. And I was doing more and more of them because I thought that I'm learning a lot of new things. But in reality, what happened is like even if I add also on top of that the master's degree where I studied things. So I had a lot of theoretical knowledge after doing this. After finishing these 15 courses, after doing a master's, I had a lot of theoretical knowledge. And I thought I know everything. But when I started working as a data scientist, my colleague showed me Kaggle. And for those who don't know what Kaggle is, this is a platform for online competitions. So there you, like some company comes there and says, okay, this is my problem. So this is the data set we prepared. And you can train a model on this data set, upload this model to Kaggle or the predictions, and then we will evaluate the predictions and put them on a certain position on a leaderboard. So it's like a competition. So whoever is first, like is able to train the best model wins. So that's the idea. And I thought, okay, Kaggle competition, like it's machine learning. I finished so many courses. I did a master's. So for me, it should be super simple because I know everything. Like I know how to derive all these algorithms. But in reality, what happened when I attempted to take part in a Kaggle competition, what happened is I failed miserably. So my first submission, like I think it was somewhere at the bottom of the leaderboard. And it was so painful. Like I couldn't do much there. And I had to learn a lot there, like to see how others are doing. And this made me realize that all this theory, everything I learned was useless. Like, and at the end, it wasn't really helping me to get any position, any good position in the leaderboard on Kaggle, because all I was getting was the bottom positions. So I started actively playing on Kaggle, investing time there, learning from others how they do this. And on Kaggle, it's a lot of engineering work again. So you don't really care about theory there. You care about feature engineering. You care about how you design cross-validation. All these things, I don't know if you know what they mean, but at the end of the day, you need to write a lot of code. And as a software engineer, you already know how to do this. You just need to focus on projects. So instead of focusing on theory like I did on online courses, you need to focus on projects. And this is what I suggest you to do. So instead of going through a lot of theory, do projects yourself. Get your hands dirty and learn from that. And I think as a software engineer, this is the best way I learn. And I learned that on Kaggle as well, because when I started playing on Kaggle, when I started getting some side projects, this is when I really learned machine learning. So my suggestion to you would be get your hands dirty early on. Don't invest a lot of time in doing online courses and just go on Kaggle or anything else and do projects there. So, okay, I promised to start with fundamentals. So what are the fundamentals? So for me, the fundamentals are, if we are talking about data science and machine learning in general, the fundamentals are Python, then NumPy, which is a library for number crunching in Python, and Pandas, generic data manipulation tool. So I think these three tools, they are fundamentals. And maybe you notice that I don't really have math here, and you may ask why. Because again, I think if we are talking about applied machine learning, applied data science, then what we need to do, what we need to really ace is data preparation. Like how do we prepare data? How do we take this data and convert it into matrix, put this into a machine learning library? So we don't really need a lot of math here. At some point we will need, but not at the beginning. At the beginning, we just need to learn how to use these libraries. And I want to show something scary. Scary for many software engineers. maybe for people coming from PhD, this is not scary at all. People coming from mathematics or physics, this is what they love. But for software engineers, every time they see this, they get frozen. And I was such a software engineer. Every time I saw this, my mind would just go blank. And because I think my theory is we got tortured at university with math a lot. At least this was the education I had. We just needed to solve a lot of mathematics, like a lot of problems in math. And nobody would really tell us why it's important. Why do we need to care about all this mathematics? And it left a scar. So every time, at least back then, when I saw a formula, I remembered those days at university, like sitting on a linear algebra and doing the exam and then getting this super complex problem. And then I needed to solve this problem on the exam and I had no clue how to do this. And this is how I felt when I was transitioning from software engineering to data science. Like all these formulas, like all this linear algebra that I didn't really like. I did like the calculus part at math at university. I don't know why, but algebra, I really struggled with algebra. So like my mind would just go blank when I saw this. And I think this is a really common fear among all software engineers. It's like every time we see this, we get scared. But I don't know if it will work. What I'm going to say is, of course, like if you're scared, I can tell you, don't be scared. I don't know if it's helpful, but if you think about this formula, so here we have just a bunch of matrix multiplications. So we multiply matrices, then we take an inverse. So all these operations, like if you take a look at them, all these operations, they can be expressed as a bunch of for loops. And when I realized that this matrix multiplication is nothing else but a for loop, then these formulas, they stopped looking so scary. And what I would suggest to you, like if you get this fear of math and especially of linear algebra, as I did, just try to see this as a bunch of for loops. And for you as a software engineer, for loops are not scary. This is something we need to write on daily basis. Like if you wake up in the middle of night and somebody asks you to write a for loop, you will be able to do this with your eyes closed, right? And if you think about matrices as for loops, then things become easier. And this is a tip and home task. So you don't need to think about this right now, but maybe after this talk, when you rewatch this again in recording, what you can try to do is you can try to implement these matrix operations yourself. So we have a bunch of operations in linear algebra, like vector-vector multiplication, then matrix-vector multiplication, then matrix-matrix multiplication. Try to implement all these things in code with just a for loop. And then you also, like once you do this, you can also try to express each operation in terms of the previous one. So let's say you wrote a vector-vector multiplication, which is a simple for loop, just one. Then you can reuse this to implement matrix-vector multiplication. And once you do this, you can use matrix-vector multiplication to implement matrix-matrix multiplication. We will not go into that anymore today. This is something like if you have this fear of math, I recommend you to do that. It will take a couple of evenings for you, but after that, I promise you will not be scared when you see linear algebra equations, because you know that at the end, this is just a bunch of for loops. And as I said, that the best way, I think, for software engineers is to learn by doing projects. And this is nothing else but a project. Like you take this theory, you take this complex expression, and you try to implement this yourself. And once you do, at least this is how it works for me. Once I implement this, then I understand how it works, because I can implement this. And now I have this, I don't know, 100 lines of code. And it's clear to me what's going on, because I can implement this, I can reproduce the results, I can rerun it with new data, and everything is clear. So that's why I think the best way for software engineers is to learn by doing and to learn by doing projects. And as a software engineer, you should really focus on projects. So the project is something that has a clear goal, a clear purpose. There is some objective, and you work on solving this, solving this problem, on reaching this goal. And this is what I did for my book. The book is Machine Learning Bootcamp. So I tried to put it as based it on projects. So there are different projects. And what you look at right now is the dependencies between the different projects and different chapters. And again, even if you don't have the book, you can still use this picture here to plan your own learning. Because you see that, for example, if you want to learn how to use tree-based models, for that you need to understand classification, and for that you also need to know a bit of regression, right? And then if you want to deploy a model, then you need to understand this and this and these topics. So it helps you to structure your learning in a way that like going from simple to more complex things. And I definitely recommend to have something like this. You can use this one, or maybe you can try to come up with something else or find something else on the internet. But my suggestion, my recommendation would be to structure your learning in a way that it goes from simple to complex. And you also try to deploy early on. So there's a chapter 5 on deployment, which where you get a model you trained and you try to deploy it, because without deploying your model is useless. I'll go in more details here. So what I want to give you now is 4 projects, that you can implement yourself or by following the source code from the book, which is public. So it's on GitHub. You can just open it and take a look. And after implementing these projects, these 4 projects, you will have a great portfolio of projects that you can use for looking for a job, for example, or not or, but and when you implemented all these projects, you will know all the basics you need to work as a machine learning engineer or as a data scientist, because these 4 projects will help you to fill that gap. So remember, I said that you as a software engineer, you already 90% ready to be a machine learning engineer. You just need to fill this 10%. And with these 4 projects, I think you'll fill at least 5%. So at least half of what you need. So the first project I suggest to do is predicting the price of a car. So imagine you have a car, and these pictures, I took them from OLX, but like you can just take any data set. So there are many data sets with cars on the internet. You can just take any of them. And for each car, there are a bunch of different characteristics. So each car has a model, each car has a make, mileage, all these things. And each of them has a great impact on the output, on the prediction, how much this car costs. Because if a car is old, like if we look at the year when the car was manufactured, if a car is old, then it's cheaper. If a car is new, then it's more expensive. So there is some relationship. So you take this data set and you try to predict the price of a car. So this is a really great introduction, like as a first project for you to implement when you just start with machine learning, because first of all, this is a relatively simple problem in terms of understanding, because you understand what the car is, what kind of characteristics this car has, and what is the price. So you have the understanding of the problem. And so you really have all the context, and this becomes like it makes it easier to work on this project. And then yeah, so you can take a look at the notebook that I prepared, but you don't really have to do this. So you just take a data set and then you try to prepare this data set in a way that you can put this to some scikit-learn model, a linear regression in this particular case, and just try to make it work. And Google is your friend, because as a software engineer, I am pretty sure you know how to Google, and that's all you need. That's all you need to solve this problem. Then the second project I suggest to do after you finish the first one is a churn prediction model. So churn is something that let's say you have some customers of a company, and some of these customers decide to stop the contract with the company. They decide to leave the company. They decide to stop using the services of this company. This process is called churn. And we as a company, we have a lot of customers, and we want to identify users, customers that are more likely to churn. And if we know that this group of customers, they are more likely to stop the contract with us soon, what we can do is we can give them some incentive to stay. We can give them some promotion, or try to convince them to stay. And this is also a nice problem, because this is really applicable to many industries, from e-commerce to pretty much every software as a service business. So this is a pretty widespread problem. And so this is a real life problem, and you can try to find some data set with this. So there are a few data sets on Kaggle with this. And yeah, so what you can do is, again, like in the previous example, you take the data set, you do some preprocessing, and then instead of putting this to linear regression, you put this to logistic regression, because this is a binary classification problem. So you want to predict if a customer is going to churn or not. So you do that. And the next step, what you can do is you need to evaluate the model. And I think this is one of the most important parts of applied machine learning. So it's not about the math. So not the math that is important thing, not all this algorithm, but being able to implement the model, to evaluate the model. I think this is the most important thing. Because if you know how to do this, if you have a way to measure the performance of your model, then you can know that this model is better than the other model. Or you can say, okay, this model is simple and it's not much worse than this complex model. So being able to do this, being able to experiment, I think this is the cornerstone of machine learning. So I'm talking about things like cross-validation, like evaluating the performance of your model, and then also metrics, like what is accuracy, what is precision, what is recall, what is F1 score, things like this. I think this is really important, and you really need to know these metrics. And also it's complex. I know that this is like, these things are rather abstract. That's why I think if you put them in practice, if you implement this from project and you try to play with different models and see, okay, this model has better precision than this one, it really gives you the feeling, okay, like I know what I'm doing. So I really recommend spend some time on this, even though it's rather abstract and complex, but it really pays back to know these things well. Another important topic is deployment. So once we have a model, once we trained the model, once we evaluated it, we think it's a good model, what we need to do next is we need to deploy it. Because if you have a great model, but it's not deployed, it's a useless model. The good news here, you as a software engineer, you already know how to do this. So this is relatively easy, because for most software engineers, our job is to actually build web services. So we already know how to do this, even though maybe for me, when I was doing this in Java, not in Python, but the concepts are pretty similar. So for software engineers, this part is not that difficult, but it's also very important. And this is where we really have the advantage, because we know how to do this already. And yeah, so when we have a simple model, so the model doesn't have to be complex, we can quickly roll out a web service with this model, with this simple model, and it can already be beneficial for the business where we work. And this is our superpowers. So as a software engineers, we can do this relatively quickly. We can just take a model. We don't need to be experts in machine learning, but if we can use a library, scikit-learn, if we can take the data set, if we can train a model, we get this model and we put them in this model in Flask or something else, we can serve it, then this model becomes useful. This model can be used later to make predictions, to make some money, to make profit for the company, and everyone is happy. So this is an important topic, and we already know how to do this. Then after you do this, so after you really understand how to do evaluation of models, after you understand how to deploy models, you can take another project, a more complex project, because in the previous project we use, I suggest to use something simple like logistic regression, but then you can take another project, also binary classification, and play with something more complex, with some other complex model, more complex than logistic regression. And here I'm talking about, I'm proposing to try to do a credit risk assessment project. So let's say you are working at a bank and people come to you and ask for credit. Like, I want to buy a car, but I don't have enough money. Can you please give me the credit? And what bank is doing? They are running some credit scoring analysis to understand if you as a customer will default, meaning not be able to pay back or not. And banks have a lot of information. They know like who previously wasn't able to pay back the loan. So they have this data and they can build a model for predicting the risk of not returning the money. And there are many data sets online that you can find. And for this project, I would suggest to use a tree-based model, not just one, but you can try decision tree, then you can try random forest, and then you can try XGBoost. So in this order, to start first with decision tree, and then gradually get more and more complex models. And again, Google is your friend because all the information about this model is these models is already there. So you just need to find it to see how you need to prepare your data set to be able to use this model, then use this model. And then at the end, you have this model file that you can again put in Flask and serve it to make everyone happy. So for this project, I suggest to use tree-based models. So once you have that, you can play with something more complex. So project 4 is an image classification project. So image classification is, imagine a scenario that let's take OLX. So OLX is a place where you can sell different things. So you can sell clothes, you can sell iPhones, I don't know, different stuff. And what we want to do is build a model that understands what is on the picture. So if you upload an image of an iPhone, it understands, okay, this is a phone, this is an iPhone, and then it automatically completes, it automatically suggests the right category for this image. So you can do something similar. In this case, there is a data set with clothes that you can use. So there are 10 different classes of clothes like t-shirts, pants, shirts, dress, jackets, and things like this. So clothes, basically. And what you can do here is you can train an image classification model with Keras or whatever framework. So for example, PyTorch or like whatever you prefer. And here, instead of building a model from scratch, so there is a concept in machine learning, in deep learning called transfer learning, when instead of using like training a model from scratch, like we did in other projects, you take a model that is already pre-trained on some other large data set, and you use this model, you adjust it slightly for your purpose. So for this project, do that. If you Google transfer learning Keras or transfer learning PyTorch, you will find a lot of examples how to do this. And of course, there is also an example in the book's source code, so you can just go there and see. I would suggest actually, instead of just following this notebook, to try to implement this yourself using Google and then trying to find how to actually do this, and only occasionally look at the notebook. Because I think if you do this, then you can do things independently. If you just follow along a tutorial, then it's a bit harder to remember things. Yeah, so once you have this model, so you train this wonderful model that can classify different pictures of clothes into different categories. Like on this case, we have a t-shirt. What you can do next is you can deploy this model again. So previously, for a simple model, we used Flask. You can still use Flask, but there are other deployment options. And for this project, I would recommend to use something like AWS Lambda. With AWS Lambda, you can also serve simple models, but you can also serve deep learning models. And Lambda is really great because you don't need to care about all the infrastructure, all the servers. It's very simple So you pay only for the amount of invocations you have. So if you invoke a lambda function and it runs for 2 seconds to make a prediction, then all you pay is only these 2 seconds, and you don't pay for the rest of the time. So it's really great for experimenting, for trying, and it's really cheap. So I recommend to deploy it with Lambda. Again, you can find a lot of tutorials online. So for this particular case, if you train a model with Keras, then you can convert this model to TensorFlow Lite and put this TensorFlow Lite model in Lambda, and that will work. And then moving on, you can also play with Kubernetes, and I do suggest you do that because now in many companies, Kubernetes is the de facto infrastructure management tool. So this is what most of the companies, a lot of companies use for deploying different things. And perhaps if you already work as a software engineer, perhaps you already know how to use Kubernetes. Or at least at Elix, many software engineers already have this knowledge. So for you, if you already work with Kubernetes, it will not be too difficult. So what you need to know here is how you can actually use Kubernetes to deploy machine learning models. And for this, since we like if you train this model with Keras, you can export it into TensorFlow serving and then build a simple service before this TensorFlow serving, which you can call gateway. So trying to implement something like this, like you have on this picture. Yeah, like if you already know how to use Kubernetes, you just need to learn how to use TensorFlow serving and how you communicate with TensorFlow serving using gRPC, because not many software engineers actually need to use gRPC. This is a special protocol for communicating between different services. Yes, and this is a really great project because this is something we use in production. So if you are already like if you're just thinking of transitioning to data science, to machine learning, and you have a project like this on your CV, it will really set you apart from all the other candidates who do not have this. And this is how most of the companies, how many companies deploy machine learning using Kubernetes. And if you show that you already can do this, it gives you a great advantage over those who cannot yet do this. So you did these 4 projects, and I think you already know enough to be useful for the company to get hired as a data scientist or machine learning engineer. What you can do next to solidify your learning is take part in data science competitions. Like I mentioned, Kaggle. This is really great, and you will really know how to prepare data, do feature engineering. And remember, I said that cross-validation is one of the important skills that a data scientist has. And Kaggle really teaches you well how to set up cross-validation, how to evaluate your models. So I would suggest to take a look at a couple of competitions. You don't have to win a competition, just take a look, spend a couple of days playing with the competition, just try different things. You don't have to be great there. Like if you get, I don't know, in top 25%, this is already great. Then Kaggle is great, but also what is even better if you do your own end-to-end projects. So instead of just getting a book and following it, this is great. This will give you a necessary background or book or course. This is great. But you are following something that somebody prepared for you, right? So if you're following a course, somebody already did this project and you just follow this project. And you don't see all the complexities, everything that this project, this person has gone through to prepare this exercise. But when you do an end-to-end project yourself, you will be able to experience this yourself. And this is invaluable, especially if you have something like this on your portfolio. This really sets you apart from other candidates. And by end-to-end, here I mean something when you have an idea, you came up with an idea, then you yourself found a data set for this idea, or even better, you collected the data for that yourself. Let's take this example of the clause classification data set, right? So let's say you want to build a model for classifying clause because, I don't know, you want to sort your clause into different different categories, maybe for your personal wardrobe, right? So what you do is you can collect, you can take pictures of your own clothes for training. So then you do that. Then you deploy, then you train a model, and then you, let's say, put this model on your mobile phone. And this is great. This is an end-to-end project because you came up with a problem, you collected the data set, you prepared this data set, you trained a model, and you deployed this model. So you had the entire loop from the beginning, starting the project till the end when you deployed it. And projects like that are really valuable because you learn most doing these kind of projects. And the last one is you don't need to do this alone. So these things are complex, and at times you will feel lost. And because I suggested you, I told you that Google is your best friend. You go to Google, you try to find to type something, and you have 100 different options. And then you may feel lost. Like, how do you actually solve this problem? Which option is the best one? And oftentimes you need somebody to guide you, to help you, to select the best option, especially when you don't have this experience. For that purpose, you can join a community. And we already talked about Data Talks Club at the beginning. This is an excellent choice. You can join this community, you can ask questions, and you can also help others. But this is not the only community. You can join other communities, and for example, Quora is a good community, or you can ask questions on Stack Overflow or Stack Exchange websites. And you can also help people. And another, I think I should mention that as well, Kaggle is not just a platform for data science competitions. It's also a great community, and people really help each other to learn. And there is a culture of sharing, so nobody is hiding things. People are sharing things very openly. So I definitely suggest to check Kaggle. And I already I have talked about Data Talks Club. Do check it out. You will love it, I promise you. And yeah, this is my last slide. So in summary, you as a software engineer have all the skills you need for getting into machine learning. So you just need to fill in this remaining 10%. So you start by learning fundamentals, and fundamentals are, for this case, Python, NumPy, and Pandas. You shouldn't be afraid of math. At the end, it's just a bunch of for loops. And when you implement these for loops, you will see this yourself, and you will no longer be scared of math. And the best way of learning is by doing, and especially by doing projects. And I have repeated this thing a couple of times, but I have to say it again, that learning how to do cross-validation is the most important thing you need to do. So you need to learn that, and you need to learn evaluation metrics, like things like accuracy, precision, recall. You really have to do this. And the best way of doing this is by doing projects. So do remember to focus on that. And for you, deployment is easy because you already know how to do this as a software engineer. And finally, don't do this alone. There are people who are willing to help. Just ask for their help. And that's all from me. I think it took a bit longer than I initially planned, but I'm happy to take questions that you have.
I think this was a pretty interesting session. What we'll do is, Alexey, is we'll kind of have some queries for you. So there are quite a few queries that are already lined up, and I'll just start with some of the ones that I think would benefit the larger audience. So first, the first question that I have for you, Alexey, is yeah, as you mentioned correctly, like machine learning is a very small part in this entire picture, right? And a lot of people who come from different backgrounds, they presume that machine learning in itself is such huge. Okay, now learning the other components would also become exponentially complicated. So what do you recommend them? Do you think it's a wise idea that everybody, like every single person has to know everything around the entire system, or you should kind of just partner with people and take it one at a time? You need not be an expert in everything.
Yes. Well, you kind of summarize it well. So you don't need to be an expert, and you need to partner. That's I don't know how to say it better. And eventually, like I like this concept of a T-shaped profile. Like if you're just starting, so your expertise is in software engineering, let's say, and you are trying other things. So you're trying machine learning. You are maybe trying like as a software engineer, you already know a bit of data engineering. You already know a bit of DevOps, maybe. So you just need to like to have this T-shaped profile, and then gradually maybe your T can change from software engineering. So as you get more and more experienced in machine learning, so then you become better and better in this. So maybe then at some point you start forgetting some concepts from software engineering. And this is how I like to feel to think about this. And there might be people coming from let's say from physics. Yes, thanks.
So would you say the top bar is data science and the depth is software engineering?
Yes, because like as I said, any team needs experience in deploying models, and you as a software engineer can bring this experience. Right? If there is a team of data scientists, and these data scientists, so maybe they are coming from more traditional, by traditional I mean maybe they are coming from research, like from physics or from mathematics, or they got hired as a data scientist, and these days this happens quite often right after university. So this is their first job. So they don't have this depth of software engineering, right? And they need somebody to help them to deploy this model. Somebody who can speak the same language with them. So somebody who can understand what precision recall is, but also somebody who can take the model and deploy it into a Kubernetes cluster. And this is a software engineer, it can be you, right? And companies really need this kind of people.
Yeah. So I think this applies to all the types of people that we'll find in this world, especially people who are software engineers and people who are non-software engineers. Now, I think for the folks who are non-software, they can focus primarily on data science skills, get their depth in data science, and possibly have some wide, broader knowledge on software engineering, but not too in depth. You don't have to be a master there, right?
Yes,
so
exactly.
I think this explains it really well. So thank you for this T-shaped idea. I think it gave a pretty good perspective as to how should one think if you're a software engineer and how should one think if you're a non-software engineer. So I think So since the session is primarily focused on software engineering, I have a follow-up question for you, which is scalability. You talked about Lambda and Kubernetes. Now, I mean, scalability. I mean, you're working for OLX, which kind of operates at a massive scale. But when people are just starting off their kind of journey, okay, very likely these would end up kind of making things a little more complex. So, is it a great idea that you transition from your basic lessons onto on a scalable platform, or do you take it step by step? What should the approach be? I mean, Lambda and Kubernetes in itself becomes a different world altogether. But without seeing how your system scales, getting into the most scalable form of implementation can become a little complex for a newbie. I believe so. So, what do you suggest to a newbie?
Yes. When it comes to the projects I suggested to do this for your pet projects to learn these things, because when you are interviewing and then you say, okay, I do not have a lot of experience, or maybe as a software engineer, you have experience with Kubernetes, and you can say, I learned how to use Kubernetes to deploy models. And this just sends a message to the hiring manager that this person will not need to learn a lot of things. This person already knows how to do this. This is entirely different story from what you were asking. Like, let's say you are already working and you need to make a decision whether we should go with Lambda or we should go with Kubernetes, right? And of course here, like it's a trade-off. So if you have the scale, if you have some people who can support you from operational point of view, then you should go with Kubernetes, right? Because at the end, it will be cheaper, even though you need all these people to support it, but it will be cheaper than Lambda. But if you don't have the scale, then Lambda is great. So because you can very quickly iterate, experiment with this. You don't have to pay a lot. And let's say if you have, so I have just one as a rule of thumb, if you have, let's say, less than 1 million requests per day for something like deep learning, then Lambda is good. Once you have more than 1 million requests per day, then you need to think about something more scalable. So Lambda is really great for experimenting. There are, of course, other options. And like this is a rule of thumb. It doesn't cover 100% of the cases, so it's more like a heuristic. But yeah, I usually try to use this heuristic to decide what I should use.
Right. So I think, yeah, so what I can extract from here is the good thing about using Lambda is it takes you from 0 up to a good sizable number. After which, once you start incurring high costs, you might want to switch over to Kubernetes and maintain the entire system all by yourself internally. So I think that really makes sense. Now, we do have certain folks, we have quite a few of our friends who are non-software engineers. And obviously, some parts of the session would have scared them to some extent. So what do you recommend them in terms of being a non-software engineer and they are learning data science and the entire system, as you showed in your earlier slides, that machine learning forms only a very small bit of it. So what do you recommend to our non-software engineering friends as to what should their approach be? Because we saw software engineers approach, but would you kind of shed some light on the non-software engineers approach?
Yeah, so one of the things is this applies to many people, not just software engineers. In my experience, so this is my personal opinion, and I know people have different styles of learning. So there is one style of learning called builder. And I think I did a test online and I found out that I'm of this type. So people who have this, how to say, this style of learning, who is of the builder style, so they really like doing this. But what you need to find out is probably how you learn best. But I still recommend trying to do that, trying to build projects, because like maybe for you, like if you're coming from academia, for you, the machine learning part will be easy. But the part about deployment will be difficult. And this is what you need to focus on. But you need to close this loop. You need to go from the very beginning till the end, and you need to have a thing working end to end. For different profiles, for different people from different background, you will have to spend different amount of time on each stage. For a software engineer, you will have to spend less time on I don't know, preparing data, and you will have to spend less time on the deployment part. While as somebody coming from academia, you will actually need to spend more time on this, because this is your, how to say, weak point. Usually this is the weak point for people coming from academia, especially from more theoretical backgrounds like mathematics, maybe. Because I know that in physics, there is more coding, for example, than in some other areas. But yeah, so just focus on your, in this case, weaknesses. Of course, focusing on strengths is also important, but in this case, you want to close this loop. You want to implement all the parts for your pet projects. And this is how you will learn. So you will step out of your comfort zone, and you will learn things like Airflow. You will learn things like Flask. You do not need to go with, heavy machinery of Kubernetes, because I think that will be an overkill for somebody who is, who is used to dealing with formulas in academia, and then asking them to work with Kubernetes might be just too much. But Lambda or Flask, they are relatively simple technologies compared to Kubernetes. And it should be possible if you spend a couple of weeks trying to learn them, trying to follow different tutorials. It should be possible. I'm not saying you have to become an expert in them, but you should get some understanding how to use them. And most of these tutorials, like, they're just step 1, step 2, step 3. So you just follow these steps, and then at the end you have something working. And then next time you need to do something like this, maybe you replace some of the steps with something else. And this is how you learn. At least this is how I learn.
Yeah. So I think I would second you on that, especially the project part. There's no other way I think anybody can really learn this field properly, or even to a great extent, I can possibly even say that if you really want to get into this field, you have to have a lot of projects. You should practice on a lot of projects, a lot of different data sets. And the biggest question that I have for you as a learner in this field, somebody who started learning, say, machine learning and data science, we get lost in the volumes of competition that we see on Kaggle. What do you recommend is the right approach to kind of get started? There are like so many questions out there. There's so many different competitions which are there. All of them hold solid ground. I followed your topic-wise approach as to these are the projects that you should ideally follow. Okay, so would I find all of those projects in Kaggle as well, or it's like you're telling to find something similar on Kaggle?
So on Kaggle, you have two things. Well, you have more, but there are data sets and there are competitions. So you can start with data sets, right? So you can just take a data set and try to play with this. Competitions are also useful because in competitions, especially active competitions, people are actively sharing their approaches, right? And if you try to reproduce, there are things called kernels or notebooks. So this is essentially just a Jupyter notebook with some code that you can take a look and you can execute it cell by cell and understand what's going on there. And I recommend doing this. So of course, when there are 10 competitions, 10 ongoing competitions, you just need either to select what you like most, or sometimes in many communities, there are some sort of study groups or Kaggle groups, or I don't know. So people who are actively taking a part in some competition. So you can see, okay, here people are taking this competition. So they can already tell me a few things about this. So maybe because they are taking part in this competition, I can also take part in this competition. So just, yeah, try to look at other people who maybe who you know. Somebody who you know is taking part in Kaggle right now. Just ask this person, hey, what competition will you recommend me to join? Yeah, other than that, I don't know. Maybe at the end, you can just flip a coin and
Okay,
decide.
yeah,
It doesn't really matter.
yeah. I think as long as you kind of get started, you start working on projects on some data, not necessarily a competition though. I think that should be a good starting point. So now switching back to a software engineer's perspective, and here I have a question for you, which is around, uh, there are so many methodologies, okay, there are so many techniques. Okay, now, even as a software engineer, people oftentimes they kind of fall short of things that they're supposed to learn. So what should be the right approach in terms of getting started with, say somebody wants to build a scalable platform. Okay. Now, in a scalable platform, there can be multiple components. So something like a pipeline, something like your Dockerization, something like your Lambda. So there are like so many different approaches. So how does one decide what to pursue?
Okay, so there are so many ways of answering this question. So let's say if you have a scalable project, it means that you're already working at a company that has the scale problem. And it means this company already has competent people who know how to deal with these problems. So just ask their opinion, whatever they will recommend, use it, and ask for their help with these things. So for example, when I joined Alexey, I didn't know Kubernetes. I didn't know Terraform. I didn't know how to use these tools. And the developers, the DevOps engineers, they were always busy, but I needed to deploy something. And then it was back in the days when we had, then offices were still open and people were still in the office. So I was just drinking tea, and then the DevOps engineer came into the kitchen as well. And I asked, hey, Oli, that was his name. Can you recommend me? Like, I want to learn Kubernetes. How would you recommend me to do this? And he told me, oh, there is a thing called Minikube, which is a mini Kubernetes that you can install locally. So just install this, and there is a great tutorial in official documentation. Follow this tutorial. And then after you follow this tutorial, after you understand all the basics, try to deploy a model with this. And this is what I did. It wasn't easy. I took like 20 hours maybe to do this. But at the end, I said, hey, Ole, I did that. Can you please let me now play with the real cluster? And he said, yes, but I'll be watching you, of course. Like, he then helped me to do this. So it wasn't real production cluster, it was a staging cluster. And he was just, standing there. I was doing the whole thing myself. He was just standing there as a backup in case something goes wrong. So he could intervene and fix things. but I didn't need his help. He was there just to support me, because that was enough to actually start using Kubernetes. And this is what I would suggest you to do. Like if you have a scale problem, just find somebody who knows this, ask for advice, and and do that. But then, like if you have a scale problem and you are not working, then maybe you shouldn't overcomplicate things. Like you don't really have the scale, right? If it's your pet project, I really doubt you will have the scale, right? If it's your pet project. If you do have the scale and it's your pet project, congratulations, that's really great. Then I would advise in this case to hire a consultant and then ask for help. Then
I think the reason why I asked you this question is because a lot of people may not be as lucky as you've been to kind of have a great mentor back in OLX who could have possibly guided you. So a lot of people who work in startups, they especially face this problem very frequently, wherein based at which they're supposed to switch technology, that has become like really difficult to kind of follow on a consistent basis. So I think what I learned from this answer is that definitely, if not internally, you might always have people to reach out to externally. So you need not always have, you need not always need to have a mentor back in your company, but you can possibly join some groups where people can kind of guide you, right? So
yes.
the proactive measure is pretty important for people to build successful projects. Now, talking about data talks, do you plan to come up with your set of sequence of competition, sequence of I would say beginners to expertise, implementation guidelines? So, do you have anything like that in your pipeline?
Well, maybe eventually. So now I'm just having troubles with catching up with everything that is there already. So let's see. Yeah, eventually, if there's an ask, if people want that, why not?
I'm pretty sure your community will grow fast, and there'll be a lot of participation very soon. So I think we'll stop. We already exceeded the time by a lot. We're supposed to stop at 9, but I'm really grateful that you found out some time for us. And I'm pretty sure the community here gained a lot of value add from your knowledge that you have shared today. Especially on behalf of Insaid, I would like to extend you a big heartfelt thank you for kind of coming here and talking to all of us. And along with that, we just pray that you and your family and your friends kind of keep safe out there in these COVID times. We'll be happy to kind of follow you very regularly and see what is going on in the OLX space and what is Alexey up to nowadays. So yeah, with that, friends, can you all quickly thank Alexey and Alexey, before we go, I would like to kind of share one final slide with all our friends here. So, yep. So, friends, please make sure all of you kind of follow Alexey and Data Talks Club. There's a lot that we can learn from them. And along with that, I'm pretty sure there's a lot of valuable articles and events happening there. Join the Slack channel as well. Maybe you can kind of get connected to somebody who's really awesome in the community and gain a lot of knowledge from them. Okay, so so I don't need to repeat this slide for all of you who have been attending Europe Data Science Week for this entire week. So please follow this hashtag Insaid, and please make sure you comment and you kind of share your knowledge about what you have learned across this entire week. Especially, I would really want all of you to thank Alexey and all the other speakers who have put in their time, who have kind of shared their valuable knowledge with us. And I think what better can it be when you're learning from people across the world? Okay, so please make sure we don't forget to thank our friends out here who are coming down and helping us learn better in this field. So with that, I think that's all from our end, Alexey. It was great hosting you, and a big thank you from Insaid.
Yeah, thanks a lot for hosting me. That was really great. Thanks.
Thank you. So thank you all. We can now terminate our sessions. We are done for today, and I hope all of you have enjoyed. Do make it a point to kind of thank Alexey for the wonderful information that he shared today. Thank you, Alexey. It was a great session. Thank you.
Thanks, and everyone have a great evening.
Thank you. Same to you. Bye.